In the annals of space exploration, the Apollo missions stand out as monumental achievements, with images of astronauts bouncing across the lunar surface etched into our collective memory. However, 2 years before Neil Armstrong's famous "one small step," a lesser-known but equally significant event occurred on the Moon. On November 10, 1967, Surveyor 6 performed the first-ever rocket-powered hop on a celestial body other than Earth, marking a crucial milestone in our journey to understand and explore the cosmos. The Surveyor program, paving the way for Apollo. NASA's Surveyor program was a series of uncrewed lunar missions designed to prepare for the eventual human landings of the Apollo program. These robotic explorers were tasked with several critical objectives: assess the lunar environment's suitability for human exploration, analyze the mechanical properties of the lunar soil, capture detailed photographs of the Moon's surface, measure the Moon's magnetic properties. Surveyor 6, the penultimate probe in this series, landed on the Moon on November 10, 1967, more than a year before humans would even orbit our celestial neighbor. For about 2 weeks, this intrepid robot diligently worked through its mission checklist, providing valuable data that would prove instrumental in the success of future lunar missions. The historic hop, a small jump with big implications. One of Surveyor 6's most unique and important tasks was to analyze the mechanical properties of the lunar soil, particularly its load-bearing capacity. To accomplish this, researchers needed to examine the footprints left by the probe upon landing. However, the Surveyor probes were not designed as rovers. They were stationary landers built to survive the journey to the Moon and remain in place. Faced with this challenge, NASA engineers devised an ingenious solution. They would make Surveyor 6 hop. After about a week on the lunar surface, mission controllers reactivated 3 of the probe's liquid propellant engines. These weren't the large, powerful engines one might typically associate with rockets, but rather small vernier engines or thrusters usually used for fine directional adjustments during landing. On November 17, 1967, these engines fired for a mere 2.5 seconds. The result was a short but significant flight lasting about 6 seconds, during which Surveyor 6 traveled approximately 2.5 meters, about 8 feet, from its original landing site. This seemingly small movement was, in fact, a giant leap for space exploration. The first rocket launch from another world. Surveyor 6's hop earned it the distinction of being the first rocket to launch from non-Earth ground. But what exactly qualifies it as a rocket? At its most fundamental level, a rocket is any device that can provide its own thrust by expelling matter in one direction, causing it to move in the opposite direction due to Newton's third law of motion. This principle allows rockets to operate in the vacuum of space, unlike jet engines or propellers that require an atmosphere to function. Surveyor 6's vernier engines, though small, met this criteria. By expelling propellant, they generated enough thrust to overcome the Moon's weak gravity and propel the probe into a brief flight. This achievement set it apart from other exploratory vehicles like the Mars helicopter Ingenuity, which, while impressive, relies on the Martian atmosphere for lift and thus doesn't qualify as a rocket. Scientific achievements in stereo imaging. The hop wasn't just a technical accomplishment, it also yielded valuable scientific data. From its new vantage point, Surveyor 6 was able to capture images of its own footprints left from the initial landing. By combining these images with those taken from its original position, scientists were able to create stereo images of the lunar surface, providing a more detailed understanding of the terrain that future Apollo astronauts would navigate. Inspiring future exploration. Surveyor 6's successful hop has inspired numerous concepts for future space exploration missions, particularly for destinations with low gravity or challenging terrain. Some of these innovative ideas include hopping landers for distant worlds. Scientists have proposed designing hopping landers for low-cost, long-distance missions to far-flung targets like Pluto or Neptune's moon Triton. These hoppers could potentially cover more ground and explore diverse terrains more efficiently than traditional wheeled rovers. Steam-powered probes. A concept called Sparrow, steam-propelled autonomous retrieval robot for ocean worlds, is being developed for missions to icy moons like Europa and Enceladus. This probe would work in tandem with a stationary lander that mines water ice. Sparrow would then use this water, converting it to steam for propulsion, allowing it to hop across various extraterrestrial surfaces that might be otherwise impassable. Jump and wait method. For low-gravity worlds, some researchers have proposed a jump-and-wait approach. This technique involves launching a craft straight up and allowing the celestial body's rotation to bring a new location beneath it as it descends. This method could potentially allow for long-distance travel with minimal navigational complexity. Legacy and sample return missions. While Surveyor 6 was never designed to leave the Moon, its small hop can be seen as a precursor to future sample return missions. In the decades since, we've successfully conducted multiple uncrewed missions that have not only landed on the Moon and asteroids, but have also returned samples to Earth for detailed analysis. The Apollo missions themselves, of course, brought back significant quantities of lunar material. Conclusion: one small hop, one giant leap. Surveyor 6's brief flight might seem insignificant compared to the grand achievements of the Apollo program or the long-term explorations of Mars rovers. However, its importance cannot be overstated. This small hop represented humanity's first rocket launch from another world, a crucial step in our journey to become a multiplanetary species. As we continue to push the boundaries of space exploration, with ambitious plans to return to the Moon and eventually reach Mars, we owe a debt of gratitude to pioneers like Surveyor 6. These early missions laid the groundwork for our understanding of extraterrestrial environments and helped develop the technologies that make modern space exploration possible. From inspiring new concepts in planetary exploration to paving the way for sample return missions, Surveyor 6's legacy continues to influence space science and engineering. As we look to the future of space exploration with plans for lunar bases and Martian colonies, we can trace the origins of these ambitious goals back to that one small hop on the lunar surface in November 1967. In the grand narrative of space exploration, Surveyor 6 reminds us that every small step, or in this case, hop, can indeed be a giant leap for humankind. As we continue to reach for the stars, the spirit of innovation and exploration embodied by this plucky lunar probe will undoubtedly continue to inspire scientists, engineers, and dreamers for generations to come.